Good morning, everyone. Okay, so today we're going to look at 11-2. Hopefully you guys liked the music video I found for mean, median, mode, and range. I thought it was funny, so hopefully you guys enjoyed it as well. So today we're going to be looking more at the graphs we started on Monday and talking more about how we use mean, median, and all that kind of stuff with these. So our objectives today, we're going to use the measures of center and spread to compare data sets. Here we go, 11-2, comparing data sets. So example 1. We're going to compare data sets displayed in dot plots. So Sawyer has narrowed his car search down to 2 different types of cars. To make an informed decision, he gathers data on estimated highway fuel efficiency, or the miles per gallon, of the 2 different types of cars. The dot plots show the data for each type. Okay, so here's our dot plot for type 1, and here's our dot plot for type 2. So the first thing we want to talk about is if highway fuel efficiency is the most important feature to Sawyer, which type of car should he purchase? Well, if you're concerned about miles per gallon, which car looks better to you? To me, looks like type 2. You notice we seem to have more clustered at higher miles per gallon. Okay, so that's the only thing he cares about. I would go with type 2. Oops. Okay, part B. Sawyer wants more information about the fuel efficiency of each type. So he calculates the mean and the mean absolute deviation, which is what we call the MAD of the 2 data sets. How can these measures help him make a more informed decision? Okay, mean fuel efficiency. Yesterday you reviewed how to find the mean. Okay, remember you add up all of the numbers and then you divide by the total amount of numbers. Okay, so type 1, we found the mean was 35.75, and type 2, we found was 40.25. Okay, so it's still looking like type 2 is better. Okay, we have almost 5 miles per gallon more. Okay, so that helps us kind of support that decision. But let's talk about the math. Sawyer also wants to consider how much his data vary to determine reliability. The mean absolute deviation, let me put it on highlighter here because this is important. The MAD is the mean of the differences between each value and the mean. Okay, this tells you how much the data varies. Okay, so I want to know if my data is really spread out or if it's really close together. Okay, that's what I mean by vary. So to calculate mean absolute deviation, we calculate the absolute value of the difference between each data point and the mean. Then we find the mean of those differences. To be honest with you guys, I have actually never ever done this in any class I've ever taken. So this is something new to me, and it's kind of a pain in the butt to calculate. So I'm going to walk you through how to do it by hand, but then I'm going to show you a shortcut. Okay? So in all the stats classes I've taken, I have never calculated the mean absolute deviation. So it just blows my mind that this is in our textbook. But here we go. Okay, so let's look at type 1. Okay, type 1, they decided to just list the data points. Okay, remember we saw the dot plot, it was pretty easy to see what numbers we have. So what we're going to do is we're going to take each of those values and we're going to subtract the mean from it. Okay, so my first point I had was 33. So I take 33 minus the mean. Okay, I get negative 2.75. But remember, it's the absolute deviation, so take the absolute value. So that's how I get positive 2.75. Okay, and I had 2 dots at 33. Do the same thing with 34. 34 minus the mean, take the absolute value. 35 minus the mean, take the absolute value. Okay, all the way up to 41. Okay, so I had 2 33s, 3 34s, 3 35s, 3 36s, 2 37s, 2 38s, and 141. So instead of adding these over and over again, I can say, oh, I'm just going to take this times 2. Okay, and then this times 3. That's how they get this. Okay, and they keep going through all the way through. Okay, and I get a total of 26 when I add them all up. Okay, so the sum of all the differences between the data points and the mean is 26. Okay, but however, we want the average. So we need to divide by the total number of numbers. So I add 2, 5, 8, 11, 13, 15, 16. So I'm going to take 26 and divide by 16. And I get 1.63. Okay, so the MAD type 1 cars is about 1.63. This means that these cars, differ from the mean on an average of about 1.63 miles per gallon. Okay, so that's showing that they are clustered pretty closely together. Okay, make that make sense. The mean absolute deviation tells you on average how far each data point is away from the mean. So that's how we do it by hand. You can do the exact same thing using type 2 this time. Okay, I don't want to calculate this by hand. It's a pain in the butt. So I'm going to show you how to do it on Desmos. Okay, so we're going to calculate the MAD for type 2 on Desmos. So I'm going to go back really quick to the data set because I don't have it here. Okay, and we're going to look at it so I can see what I'm going to be calculating on Desmos. I'm going to go ahead and pull up Desmos. Okay, so I actually already have it up, so I can find my mouse. There it is. Okay, the cool part here. Okay, so Desmos, we're used to thinking of it as graphing. If I pull up this keyboard, I'm going to go to Functions. And they have a tab called Stats. If I'm looking at this, right here, they have MAD. So let's type in MAD. Now, all we have to do is list the data points. Okay, so I had 35, 36. So I'm going to type 35, comma, 36. Let's see what else is next. Then we had two 37s. 37, 37. We had 38. Two of those. Okay, two 39s, two 40s. Okay, 141, 142, 143, so 41, 42, 43. Two 44s and a 51. Much, much easier to use this technology. So we get a MAD of 2.94. Okay, so that's how they get the 2.94. Okay, so if I'm really thinking about this one, this means that data set number 2 varies from the mean about 2.94 miles per gallon. When we're talking about MAD, we usually want our MAD to be smaller because that means there's less variance. Okay, it means they're clustered closer together. So while the mean fuel efficiency for type 2 cars is greater than type 1, there's more variation with type 2 cars. This could mean that the mile per gallon is less reliable for type 2 cars. Okay, so type 1, even though it might be lower, it's going to be more reliable. Okay, so that's where the MAD can help us calculate things. Okay, so let's look at another problem here. How does the outlier in the second data set affect the mean and the MAD? Well, remember, an outlier is a data value that's very different from the others. If I'm looking at this data set, does one appear to be way out there? Absolutely. 51 is an outlier. So 51 is much higher than the rest of the data. So what do you think it's going to do to the mean and the MAD? If you said it's going to make the mean and the MAD higher, you are absolutely correct. Okay, the outlier is going to throw those off, and it's going to make them a little higher than what they would really be without the outlier. All right, so let's move on to box plots. Okay, box whiskers. Caitlin and Philip go to neighboring high schools, and both are sponsoring charity fundraisers. Caitlin claims that students at her school are raising more for charity than the students at Philip's school. The amounts raised by a random sample of 30 students at each school are shown in the box plots below. Do the data support Caitlin's claim? Okay, so Caitlin says her school is better than Philip's school. So let's take a look at these box plots. Okay, so if I'm looking at this, I would probably list my 5-number summary. Remember, the 5-number summary is the minimum, Q1, the median or Q2, Q3, and the maximum. So Caitlin's minimum was 25. Her maximum was 68. First quartile was 32. Median was 45. The third quartile was 52. Philip's school had the same minimum, same maximum. However, his first quartile was 45. His median was 50, and his third quartile was 56. They also include one other value here in this chart. It's called the IQR, the interquartile range. To find the interquartile range, you just take Q3 minus Q1. Okay, so Q3 minus Q1, 52 minus 32. That's how they get the 20. Q3 minus Q1, so 56 minus 45. That's where the 11 comes from. Okay. So what do you think? Is Caitlin's school doing better than Phillips? Well, the max and the min are the same. The spread of the data points between the maximum and the minimum values vary. So remember, between each quartile is 25% of the data. Okay, so from here to here is 25%. From here to here, it's another 25%, right? Okay, so we have 25% of the data between each of those quartiles. So the sample data shows that 50% of the students at Caitlin's school raised between $32 and $52. Okay, there's 50% in here. Phillips school, 50% is from 45 to 56. So based on the data, 50% of the students at Caitlin's school raised $45 or more. Phillips school, 50% raised $50 or more. So whose school is doing better? The answer is Phillips. Okay, so the data does not support Caitlin's claim. Instead, they suggest that individual students at Phillips school raised more money than the students at Caitlin's school. Okay, so data can prove or disprove claims. Okay, so let's talk about this one. How does the IQR of the money donated compare to the range for Caitlin's school and Phillips school? Okay, well, we need to find Caitlin's school, the range for Caitlin, and the range for Philip. Okay, so let's do Caitlin here, Philip here. Okay, the IQR we actually just had on the last page. I'll go back so we can get those datas. Okay, the IQR was 20 and 11. Okay, so 20 and 11. Okay, let's talk about their range. Remember, the range is the max minus the min. So 68 for both of them. Yeah, I think 25. 25. So for the range, we do 68 minus 25. You get the range is 43. And that was for both of them. Okay, so Philip has a smaller IQR, but they both have the same range. Okay. And moving on to histograms. A marketing team compares the ages of a random sample of 30 viewers of two popular news shows to decide which product to advertise during each show. During which show should the marketing team advertise a product that is targeted at adults aged 20 to 29? Okay, so show one. I'm looking at 20 to 29. How many people do I have? Well, 20 to 24, there's nobody. 25 to 29, there's 8. So we have 8 people total and 20 to 29 for show one. Let's talk about show two. Okay, 20 to 29, I'm looking at these two intervals. Okay, 20 to 24, we have 3. 25 to 29, we have 5. So how many total do I have? I have 8. So, which one would you pick? I probably would pick show two because looking at it, we have people in both categories. Okay, this is only a sample. Because I have people in both categories, I'm probably gonna have more people when I do the actual show for real. Okay, because show one is totally missing that 20 to 24, and show two has it. To me, show two would be a little bit better. Okay, so I would pick show two. Okay, using the same data, what happens if we want to target at adults 25 to 34? Which show would you pick? So again, I'm checking 25 to 34, so I'm looking at these two bars. So I have 8 and I have 10, so I have 18 total. And then 25 to 34, looking at these two bars, I have 5 and I have 4, so I have 9 total. No brainer here, you would go with show one. Okay, lots more people in that category. Okay, so now we're going to make observations of data displays. Nadia collected data from 15 classmates about the average number of text messages they send on school days and the average number of text messages they send on non-school days. Nadia organized her data in the tables below. I can use a box plot to compare the data that she collected. Okay, so we have 15. Okay, so you guys remember how to make a dox plot or a box and whisker plot? Okay, so the first thing we should do is put the numbers in order, right? Okay, so let's do this guy in blue. So my smallest is 0, and I see 4, 8, 9. Okay, I'm seeing 14, 15, 16, 17, 18, 19, 22, 23, 25, and 6. Oop, I missed a 19, so I'll squeeze another 19 in there. Okay, and I always like to count and make sure I actually have all the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I'll find the mean. Obviously, the max and the min are easy. Here's the min. Here's the max. Okay, let's find the median. Okay, there's the median, or Q2. Now we need to find Q1. Okay, here's Q1. Q3. Okay, so minimum 0, max is 26, Q1 is 9, median 17, Q3 is 22, and we can always find the IQR as well. Remember, 22 minus 9, this gives me 13. Okay, repeat the same thing for non-school day. Okay, I'm not going to do that again because we have the data right here. Okay, minimum would be 0, max would be 80, Q1 is 40, median is 50, Q3 is 60, and then we have an IQR of 20. Okay, so after I calculate my 5-number summaries, I want to use the information to create a box plot. Excuse me, can't talk today. Okay, so I'm going to start off by making my number line. And I went from 0 to, what was it? The highest we had was 80. Ooh, some big numbers here. So I don't know about you, but I am not counting out 80 lines. So I'm just going to go by 5s. So 0, 5, actually, 40. I like to put everything in to make sure I can do it right. Okay, if you wanted to, you definitely could put 5 dashes in between each of those. I don't want to, so I'm not going to. Okay, so let's start with our school day text. Okay, I'm going to scoot that down so I have some room here. Okay, first thing I want to do is put, okay, I'm going to do this one in blue. And my minimum was 0, so I put a dot on 0. And my maximum was 26, so about right here. Okay, and then I put my quartiles in. Q1 was 9, so we'll do a line. The median, or Q2, was 17, so another line. And Q3 was 22, so another line. Remember, connect the 3 lines. So there's your box, and then do your whiskers. Okay, so that was school day text. I'm going to do non-school day text here in red. Okay, so again, minimum was 0. So I put a dot on 0. Maximum was 80. Okay, Q1 was 40. Median was 50. And Q3 was 60. Okay, connect my lines to make my box. And then draw my whiskers in there. So, what do we think? Okay, we are comparing these. Well, first thing you should see is that the non-school day texts have a much, much larger spread. Okay, look how big that box is compared to our little blue box. Okay, so you should be saying non-school days, we have a much larger spread of text messages. Okay, non-school days, our data is clustered much closer together. You could say that the 25% of the data for each of them is much bigger on the non-school days than it is for the school days. You can say that the minimums are very obviously the same. The maximums are hugely different. Okay, there's lots of things you can tell me from here. Okay, so there's my two box plots. Okay, so let's provide a possible explanation for each of the observations made about her data. Okay, so here's some observations that she made. Students send far more text on non-school days than on school days. Why do you think that is? Well, non-school days, you have a lot more time to be on your phone. Okay, I know I play on my phone a lot more when I am not at school. Okay, tell me why you think there's more variation in the number of texts sent on non-school days. Well, to me, the variation could be maybe we have a kid here who doesn't have a phone. Maybe we have some people that don't have as many friends and they're not talking as much. Maybe some parents limit how much time you can be on your phone. Okay, things like that. Okay, another observation, one person does not send any texts on non-school days. This represents an outlier. So why do we think that is? Again, maybe that person doesn't have a phone. Okay, so just coming up with some explanations for these observations. Okay, can you tell me two more observations? Okay, just two other things you notice. Okay, and that's it for 11-2. So here's a summary. Remember dot plots. We can compare data using statistical measures of center and the measures of variability. So dot plots show how a particular data point fits in with the rest of the data. Okay, for a more specific measure of variance, we find the MAD. Box plots show your min, your max, and the measures of center. And then histograms allow you to easily compare data ranges. Okay, so some interesting points there. Homework tonight. Okay, you're on page 478. I'm giving you 3 problems. Now, these 3 problems, you need to make sure you're following the directions fully. Okay, read the directions. Don't just go straight to the problem and think you know what you're doing. Okay, the directions, there's quite a bit of things you need to do with each of these data sets. So please make sure you're paying attention and reading the directions fully. As always, please email me if you have any questions. Hopefully you guys like this stuff. I think stats is very interesting and I really enjoy stats. So have fun.